replaced. Then the port will be 8081. Open up deployment, and here let's just make one replica, and for customer as well. So one replica. And as I said, in production, you want to have maybe 3 at least. So here, go back to deployment, and the image is fraud. Container port, this is 8081. And there we go. Let's do the same for notification. Command C on fraud, name it notification, and then perform a search and replace. And you can see the keyboard shortcut down below. So this time, this will be notification, and instead of customer, this will be fraud. Replace all, replace, and then for the port in here, this will be 8082. Open up deployment, notification latest, that's the correct image, and then the port is 8083. And to be honest, this is it. Next, let's apply these YAMLs. So if I cd into Kates, and let's also cd into Minikube. So here within Minikube, say cube ctl apply -f, and I want to apply services. Let's first apply customer. So we one replica now. There we go. Let's also do the same for fraud. There we go. And now for notification. Awesome. Now you can see that we have a service which was created for both fraud and notification, and the service for customer wasn't changed because we didn't change anything there, but the deployment was configured because we changed the replicas down to 1. Now let me say get pods, cube ctl get pods, and have a look. So this is kind of cool. We have notification right here, which is up and running, and also fraud, which is up and running, and customer now is back to 1 replica. Let's have a look at the logs. So cube ctl logs, and then the name of the pod. So let's try fraud first. There we go. You can see that Tomcat started on port 8081, which is cool. And you can see the create table, fraud check history. Let's check the logs for notification as well. So get pods. This is notification, and logs for notification. And check this out. So notification is also up and running. Right here, started. You can see create table notification, and also we managed to connect to RabbitMQ in here. So new connection created, which is really, really cool. All right, next, let's go ahead and see how we're going to test all of this to make sure that indeed the application is working as it should. The first thing I want to do is scale down customer and drop and recreate the customer database, because I know this will cause me issues. So before, remember, I had 2 replicas up and running for customer, and because one pod created a database and then the second one came along and then also destroyed a couple of things, then I know this will cause me issues. So let's first scale down customer. So cube ctl and then scale -- replicas equals to 0, and then say deployment and then customer. There we go. So now that we have 0 instances of customer, so if I say cube ctl get pods, you can see that customer, it's no longer here. Let's go ahead and run some commands inside of our Postgres pod. So psql, so kubectl exec it postgres -- psql capital U amigos code, and here let me just say drop database and then customer, and you only have to do this if you have more than 1 replica for customer. So there we go. Now instead of dropping, I want to create the database again, so we're going to need it. So create database and then customer. All right, so now I'm going to press Ctrl D, come out. Let's scale customer again. So instead of 0, we want 1 back. There we go. You can see deployments, apps customer scaled. And if I say kubectl get pods, you can see that customer will be up and running in a second. So don't really trust this right here. That's because we don't have any liveness nor readiness probes configured. But our application really takes about 10 to 12 seconds to be up and running. So this now is up and running. Now let's have a look at the services. So kubectl get svc, and we have customer, fraud, notification. Now fraud and notification, these are internal, can only be accessed by internal pods, but customer is type load balancer as well as Zipkin. Now you saw that if we want to access our load balancers, we can just say mini cube and then tunnel. Now I need to add in my password because of port 80 needs privileges. So add in my password, enter, and as always, wrong password. And there we go, it works. Now let's open up Postman and we can send a request to customer on this port, which is 80. So before we were accessing on 8080, but because we've changed the service to listen on port 80, we just have to say localhost, and then let's send the same payload as usual. And this time the request should go through all microservices. So send, and check this out, 200 status code, which means that it did work. Now we can go and check the logs and all that stuff in the database, but I can guarantee you that it works because of the status code. Let's also check Zipkin. Zipkin is listening on localhost 9411, and let me just refresh this. There we go. And I can even go to dependencies, and this should show me all the dependencies. But have a look, currently customer pushes to the queue, notification picks it up from the queue, and then we have customer as well that talks to notification. So this is kind of cool. But what I want to show you are the traces. So I want to run the query, and we no longer have Eureka server sending a bunch of noise, but have a look, we have the request with 6 spans. And before, I think we used to get 8. Click on show, and there we go. You can see that this is working beautifully. If you had any issues getting this far, please do let me know. Otherwise, catch me on the next one. In this section, I want to focus on Kafka, and I want to build a little project using Kafka so you see how it works. But then towards the end, I'll basically let you go off and explore how you're going to change the existing application, which is using RabbitMQ, so that you can integrate with Kafka. Now, the reason why I want to teach you Kafka is because you should know both. And you'll see that because we are using Spring Boot, then the integration with Kafka is also really straightforward. Without further ado, let's kick off this section. So in order for you to understand what Kafka is, I would highly recommend you to go and enroll to this course right here, where I teach you everything about microservices in terms of setting up everything from scratch, microservice communication, connecting to databases, logging, and a bunch more. So basically everything in here that we are doing. And previously we actually did connect to a RabbitMQ in here. So if you've missed that video as well, I would highly recommend you to go and check it out. Now, because we are learning about Kafka in here, we just have to replace this part right here, because Kafka can be also used as a message queue. So let's dive into Kafka to understand what it is. Kafka is a distributed streaming platform that allows producers to send events of streams right here to the broker, and then consumers can actually receive those events. And the way it works is through topics, and I'm going to explain topics in a second, but Kafka is a distributed streaming platform. Now, you might be wondering why distributed. Well, you can imagine that you want your application to be resilient, i.e. you don't want just one node to act as your Kafka broker. And instead, you can have 2, 3, 4, or thousands of nodes. So these are brokers that basically run your Kafka process. So these could be cross-region, different data centers, so on and so forth. And with Kafka, you can build real-time event-driven applications, such as, for example, location tracking. So maybe if you order food from Uber Eats, then when you see the driver updating his location on the app, that is done through Kafka. Kafka is fault tolerant, so you run a bunch of these nodes cross-region. It can scale, so if you basically need more brokers or if traffic increases, Kafka is highly scalable. And as I said, Kafka should always run as a cluster. Now, one difference here that you might be saying, okay, so what's the difference between Kafka and RabbitMQ, for example? Well, with Kafka, messages, when they are sent to the topic, they don't disappear. So they can stay there for a couple of minutes, couple of hours, couple of days, or even forever. Whereas in a traditional message queue, the messages are gone as soon as they are consumed. So we have producers and we have consumers on this side. Producers, these could be microservices or web application or anything really that wants to produce messages or events of streams. And then you have consumers. So again, this could be microservice to microservice communication, or maybe you want to send logs as well, or you want to build monitoring systems, including dashboards, or even do work with Hadoop. Also right here on the side, you can see that Kafka has something called Kafka Connect. So these are mainly for data integration. You've got Kafka Connect source. So this pulls data from your existing data sources into Kafka. And then you have Kafka Sync, which takes data of Kafka topics and then puts it into your data source. So the connect right here, so these are Java applications that run independently from the main process. There's also something called Kafka Streams. So this is a Java API, and it's mainly used for data processing and transformation. You can enrich data, you can transform data, you can perform filtering, grouping, aggregation, and a bunch more. Now here you can see that the arrows go both ways. So as data comes to Kafka, basically Streams performs all of these data processing, and then once you're done, you can actually put it back to a topic so that any other consumer that wants to consume that enriched data, they can do so. Now let's look where these events of streams are put inside of Kafka. So with Kafka, we have this concept of topic. And if you've seen my RabbitMQ, you've seen topics and different types of topics. But in Kafka, it's a little bit different. So a topic is a collection of events which is replicated and partitioned. So if you can imagine, so if you have messages going to your topic, then if you have a bunch of nodes, these are replicated and also partitioned. Now, partition here means that, so if you don't have a node which is big enough to hold this topic right here, the topic itself is actually partitioned across multiple nodes. As I said, it's durable, so you can store it for hours, days, years, or even forever. And there is nothing that says how big or small these topics can be. So there's no limit. So you have to decide what you want to store, and you can basically have really, really big topics or tiny topics. Now, in contrast to a message queue, such as RabbitMQ, as I've mentioned, a topic in here, you can think of it as a log. So if you've done any Java using log4j, storing logs to a log file, this is the exact same concept, right? So data going into the log can be kept for hours, days, years, or even forever. And once data is read off a topic, it's still there. It's still there. Whereas with a message queue, if, for example, this is read, then it's gone. But with Kafka, it's not the case, meaning that you can then have a bunch of other consumers reading of the same topic. So we have producers that stream data of records. So these are the records in here. And then we have consumers on the other side. So in our example, we are working with microservices. So we'll have a microservice that produces and then another one that consumes these records. Now, let me quickly touch on partitioning. So as I said, there is nothing that says whether a topic can be small or big. So there's no size limit for them really. Now, you could have one node that is big enough to hold one topic, right? So if you have a massive topic, you can have one giant node to hold that. Or instead, what you could do is, so these days, as you know, we can scale up or down because of the cloud and resources are cheap. And we can have a node which is kind of a medium size, right? So in this case here, let's say that from a giant node, we go to 3 or 4 small nodes. Now, because we have the topic, so we have a topic, this, because it doesn't fit on these smaller nodes, we have to partition it. So here we have partition 1, partition 2, so on and so forth. This is the main idea of Kafka. Next, let's go ahead and build a project with Kafka. So you see the integration, and we're going to create the broker, which will run locally. We'll also configure a topic, producer, and consumer, and then we'll have everything working together by sending and receiving events of streams. So far in our microservice architecture, you've seen that we've used RabbitMQ right here so that if notification is down, for example, our application doesn't crash. Also, we can send asynchronous notifications, and we get a lot of benefits by introducing a message queue. So we've used RabbitMQ, but what I want to show you is how we're going to use Kafka. And because you understand how RabbitMQ works, then Kafka should be really straightforward. So if you look at the use cases for Kafka on their website, they say messaging. So Kafka works well as a replacement for a more traditional message broker, i.e. RabbitMQ or others, right? So message brokers are used for a variety of reasons to decouple processing from data producers to buffer and processed message, etc. In comparison to most messaging systems, Kafka has a better throughput, built-in partitioning, replication, and fault tolerance, which makes it a good solution for large-scale message processing applications. And really, they're referring to ActiveMQ or RabbitMQ. So this is exactly what we want, right? So we want a messaging system. So let's dive deep into Kafka. So by now you should know how all of this works, but let's first set up our broker in here. So I said Kafka runs as a cluster. That's why we have n brokers. Now a broker is just a VM, a machine or a VM which runs the Kafka process. You can have 2 or more, but there's no limits to how many brokers you can have. And usually some companies, they have thousands of these up and running. So a broker is just a machine or a VM running somewhere in the cloud maybe, or in premises, and it just runs the Kafka process. It manages all the partitions for us, the read and write requests, and a bunch more. Let's go ahead and set up a Kafka broker locally. In here, I'm within the official page for Kafka, which is kafka.apache.org. And you can see that they gave a brief description of what Kafka is and some of the industries that use Kafka. And if I scroll down, you can see that it's basically high throughput, scalable, permanent storage, and high availability. So it stretches clusters efficiently over availability zones or connect separate clusters across geographic regions, which is really nice. And you can see the ecosystem in here. So built-in stream processing, connect almost anything, a bunch of client libraries, as well as large ecosystem open source tools. So let's go ahead and in here navigate to get started and quick start. Within this quick start page, you can find this video that explains what Kafka is, But if I scroll down, have a look, we've got a couple of steps in order for us to get up and running with Kafka locally. So in here, I want to download the latest release. So let's just download. And within this website, have a look at this HTTP link. Let's just click on it. And then I'm going to save this into my downloads folder. And if I go back to the previous website, and now you can see that it says CD into that folder. And then we need to basically start the Kafka environment. So here we need to basically start Zookeeper. So this is where Kafka stores all of its configuration. And then we can start the Kafka broker. So let's just take this command in here, Command C, go back, and here I'm going to CD into Kafka. And now I'm going to paste this command. So this will basically start Zookeeper. There we go. And you can see that it's up and running. Now I'm going to open up a new shell. So Shift Command D, CD into downloads. And next, what we need to do is to start the broker. So here, take this command, and basically it's just invoking the sh file. So back in the terminal, I need to CD into Kafka and paste that command, enter, and there we go. So you can see that from now on, use broker on localhost 9092. So we have Kafka up and running, which is really awesome. Next, let's go ahead and build our Spring Boot application that will send messages to a given topic. So we have the broker up and running. Now let's build a Spring Boot application, and this could be, for example, a microservice that will basically act as a producer to send stream of events to our broker, which is running on 9092. So let me open up IntelliJ, and in here I'm using the Ultimate Edition. So I'm going to say new project, and I can choose from various templates. So here, Spring Initializer, Kafka -example, and I'm going to leave everything as default. Next, and right here, just pick whatever version you have in here. And for now, I'm going to select in here, I'm going to say web, Spring Web, so we can build a RESTful API, and also search for Kafka. So Kafka. So here, Spring for Apache Kafka. So let's just select the first one. We're not doing streams for now, so just pick the first one, finish, and there we go. So now we have the project right here. So if I open up the application folder and then go to pom.xml, and in here, so if I collapse this, so in here we've got the standard XML file for Maven applications, and in here, have a look, we've got Java 17 and 2 dependencies which I've chosen. So Spring Boot Starter Web as well as Kafka, and we should have one for test as well as Kafka test, and also the Spring Boot Maven plugin. To be honest, this is it. So now that we have the project all bootstrapped, let's go ahead next and start building the necessary code within SRC so that we can start publishing messages to our broker. The first thing that I want to do within SRC is to have the necessary configuration so that we can have the connection details to our broker and set a topic that we can send events to. So open up main, resources, and then application.properties. And let's have one single property in here, and this will be Bootstrap servers. So Spring Kafka Bootstrap servers, and currently we just have one. So here I'm going to say localhost colon and then 9092, and within this package right here, which I'm going to name to just com.amigos code, just like that. And I can get rid of this in here, and there we go. So within this, so this contains the code for our main application. Now, if I run this, we should have no errors, hopefully. And if I close this, there we go. So you can see that in here, Tomcat started on port 8080, which is fine. Now, within the main package, let's have another package, and I'm going to name this as config. and let's have a class called Kafka and then topic config, and let's annotate this with add configuration. And in here, so this class will be responsible for creating topics. Now I'm going to say public and then new topic, and this comes from the Kafka clients admin package. There we go. And I'm going to say that this will be Amigos code and then topic. Now inside, let's just say return topic builder dot name, and this will be Amigos code. And finally, on a new line, dot and then build. And as always, add and then bin, so that this gets instantiated and we get a new topic. So let's just restart the application. And there we go. If I scroll up, you can see that Bootstrap service, localhost 9092, and there's a bunch of other configuration that we didn't set, but this is just the defaults. And if I scroll down, you can see that Tomcat started on port 8080, which means that we are up and running. Now, if I show the cluster, you can see that our cluster also is up and running, and currently Zookeeper is also up and running. So things still intact, and we can proceed to the next step, which is to configure our producer configuration. Catch me on the next one. So we've got the configuration for a topic right here. Now let's focus on the producer so that we can produce stream of events. So back to IntelliJ, and still within config, let's create a new class. This will be named as Kafka producer and then config. Let's annotate with add configuration here, and we're going to have few things. So one is, if I put this full screen, I want to have the variable that will hold the Bootstrap server URL, so private and then string and then Bootstrap service, and this will come from value. And remember, so within our configuration file we have spring dot and then Kafka. And if I show you, so here basically I just want this, take that, go back, and let me just replace here, job done. Now we need to have the configuration that we can pass to a producer factory. Now this has to be in form of a map data structure. So let's just define that, public and then map, and we want to basically have the key to be a string, and then this will be object because it can be anything really. So maybe you want to have an integer or a string or a class or anything, right? So here I'm going to say producer config, and inside let's define the map. So new hash map, extract this to a variable, and I'm going to say props for property. Now let's say props dot put, and I need to put this configuration here called producer and then config, and this comes from Kafka clients producer dot, and then have a look. We can basically specify a bunch of configuration in here, but the one that I'm interested is the Bootstrap. Oops. So Bootstrap service, comma, and then the value will be Bootstrap and then service. I also want to define the serializer. So this is key and then serializer class config, and this in here will be so string serializer from Kafka common serialization dot class. So the key will be a string and also the value. So let's just duplicate this, and here I want to say dot and then value serializer. And for now, let's just say that we will send strings. And finally, let's just say return and then props. There we go. And this has to be a map, just like that. And also I just realized that the extraction didn't work. as I wanted. So this has to be a string, and job done. Now let's define the producer factory, which is responsible for creating producer instances. So here we need to have a public method, and I'm going to say producer and then factory. The key for this will be a string, and the value will be a string. And if you were to, for example, send a Java object, right, so your own class or record, this would be, for example, customer or maybe notification. But for now, let's just keep things simple and have a string in there. And I'm going to name this as producer and then factory. And within this method, all I want to do is to say return new and then default Kafka producer factory. And one thing that I need to pass inside is the config. So producer and then config. And finally, now that we have the producer config, which allows us to create Kafka producers, we need a way for us to send messages. Now, this is possible with the Kafka template. So Kafka and then template. So the template also will be of type string and then string. So this is using generics. And again, if you were to send, for example, a custom object, this will be that custom object data type. So let's just say here Kafka template, and inside of this Kafka template, I want to return new and then Kafka template. And Kafka template, if I press Command P in here, takes the producer factory. Now, this producer factory, let's just instantiate it as a bean. So at and then bean. And let's take this in here, Command C, and we're going to paste it inside here. And so this is using dependency injection now, and then pass the factory inside, and job done. And last but not least, so that this works, we need to say at and then bean. And there we go. Now that we have the producer configuration, next, let's go ahead and learn how we're going to send a message to our topic. Our broker is running on 9092. We also have configured the producer. Now let's see how we're going to use our producer, which is kind of a microservice really, and send a message to our topic that we defined. So let's open up IntelliJ, and within project, open up the Kafka example application in here. And this really should be named maybe Kafka application. So let me just rename that to Kafka application. I think it sounds better. Okay. And what I want to do is I want to have a command line runner, and this command line runner will receive the Kafka template that we've just defined. This will be string and string, and I'm going to name it as template. And inside here, I need to return so args. So this is using dependency injection, by the way. So this right here will be this guy that we've just configured. If I go back, and here I'm going to end this with semicolon there. And now I can say Kafka template dot, and then have a look at the available methods. So we have send and pass a message, send with a producer record, with a string, which is a topic, and then the data. And we can also pass a key. So this will guarantee that the messages are delivered to the same partition if you are using partitioning. So for now, let's just say topic in here. And I want to send to the Amigos code topic. And the message will be hello, and then Kafka. And then basically end this with semicolon. Now this guy here, so Amigos code, if you forgot, so this is within Kafka topic config is this guy right here. So this is the topic that we've just defined in here. And to be honest, this is it. So obviously I'm going to change this in a second so we can have a RESTful endpoint, and from there we can basically put it inside of the topic. But for now here, let's just say bean. And with this in place, this method here will run as soon as we start the application. So let's just restart the application, and hopefully things should just work. And have a look, we have this log line in here which says add and then producer one, and in here it says basically producer client producer one and then the cluster ID. So at this point we have sent a message or a stream, and if I scroll up, I just want you to see that basically you can see that things are working. So Tomcat started on 8080 and we have no errors in here. So at this point, our application is working successfully. Next, let's go ahead and set up a consumer so that we can see this message being consumed. Within the quick start page for Kafka, if I scroll down, you can see that we can create topic. So they have a script for it. And in here, so we can basically read events. So have a look. It says open another terminal session and run this command. So here, what I'm going to do is I'm going to take this command. So let's just take this command, Command C, and open up my terminal. And at this point, I need to open up a new shell. So Shift Command D and CD into downloads and then Kafka. There we go. Now I'm going to paste this command, and before I run it, so let's just have a look. So here we just run the script passing some arguments, but the topic here, have a look, the topic is quick start events. Now our topic is called Amigos code. So let's just change this to Amigos code, and I want to read from the beginning. And also I'm passing the bootstrap server, which is localhost 9092. Now, if I press enter, we should get, have a look. So before I did have a few things inside, but we have hello and then Kafka. So this is really nice. So if I open up IntelliJ and collapse this, and let's just say, for example, a smiley face in here and restart. Let me go back as soon as possible, and there we go. So you can see that we are reading from the Amigos code topic, which is really nice. Now obviously Kafka handles lots amounts of data. So if I was to go back to IntelliJ, and let me just cancel here for a second, or hide, my bad. And what I want to do is in here, so let's just say, for example, for I, and I want to loop, let's say 10,000 times. So this is nothing, but you could loop more than this if you want. But I'm going to paste this inside, and here I'm going to say plus, and then I. If I reload and then go back, we should see, oh, have a look. So this was really quick, right? So basically with no time, it just read everything from the topic, right? So we produced 10,000 events, and you saw that it took no time. Now let's try a million, for example. So here, let me just hide this, and from 10,000, I'm going to say 1 million. So I want 1 million here. So this is 10 million. Oh, actually, let's try 10 million and see what happens. So let's just reload, go back, and have a look how it's processing everything. So you can see it's basically handling all of this with no trouble. And this is basically the power of Kafka that you are seeing in here. So eventually it will finish. Just give it a second. and boom, have a look. So 1 million records processed without no issues. So hopefully now you can start to see the power of Kafka. Next, let's go ahead and build the consumer code within our Java application. All right, now let's build the microservice logic to act as a consumer so that we can pull the events from our topic. Let's open up IntelliJ, and in here, before you saw that we pushed 10 million events into our topic, and this was nothing for Kafka. So let me just basically say 100 here because of time, and I also don't want you guys to wait around. So here, let's just open a project, and within config, let's have a new class. And here I'm going to say Kafka consumer and then config. This will be at and then configuration. And within here, so this will basically follow the exact same thing that the producer had. So let's just basically copy some code. So let's just take all of this, Command C, go back, paste that in. And to be fair, we could have made this right here a bean so that we can reuse and make it more generic. But at this point, let's just copy and paste. So consumer and then config. And let me put this full screen. And in here, let me just scroll down. And the only thing that changes really is that instead of the producer factory, so before, have a look, we have producer factory. Now we want the consumer factory. So this will be consumer and then factory, just like that. And this will be consumer config. And if I take this, Command C, and let's just paste it here. And also this is consumer. And you can see that it works. So let me just import and job done. Now, the next thing that I need to do is in here, I need to specify the listener container factory. So this will be public and then Kafka listener container factory. And this listener here receives all messages from all topics or partitions on a single thread. So let's just say that we want this to be a concurrent message listener container. And the key for this will be string as well as string. So remember, this is what we are working with. And if I put this, let's just see if I can put this on a new line, even though this is ugly. And that's because my font is quite big. And have a look at the method. So I'm just going to say factory in here and put it on the same line here. And inside now, I'm going to say concurrent Kafka listener container and then factory. And you can see I'm using keyboard shortcut there. And I don't have to remember this long class. So here I'm going to say string and then string. And I'm going to say that this is factory. And this will be equal to new concurrent Kafka listen container factory. Just like that. I want to set the consumer factory. And this will be consumer factory. And in fact, because this is a bean in here, we could just use dependency injection in here. So again, this is really ugly code. So excuse me. And this is only because my font is quite big. So let me just paste that in and just like that. So this is the argument. And now I can just pass it like that. And there we go. Now the last thing that I need to do is return and then the factory. And job done. Now let me just scroll up and see if everything is looking good. And I've actually noticed that this should be consumer config instead of producer config. So let's just change this, consumer and then config. And let's just import that. And also instead of serializer, so on this side, we want to deserialize. So let me just select here Control G, and then deserialize, just like that. And I think this should be it. If I press escape, and to recap, the producer uses a string to serialize for the key as well as for the value. And the consumer basically has to deserialize using the same data types. Later, we'll change this for a custom object, but for now, this should be good to go. Next, let's go ahead and write the code that allows us to consume events from our topic. With this configuration in mind for the listeners, let's create a listener. And within the main package, I'm going to have a class, and I'm going to call this as Kafka and then listeners. So obviously you can basically structure this the way you want in terms of packages, but I'm going to leave it within the root. So press enter. And now this I'm going to annotate with add component. And in order for us to have a listener that listens on our topic, let's have a method here. I'm going to say void and then listener. So currently we only have one listener, so listener. And within this listener, I'm going to receive the data. And because we are using Spring Boot in here, I can just say at and then Kafka listener. And here inside, I can pass the topic or topics. So I'm going to say topics. And currently, I'm going to listen from Amigo's code. And also we have to pass a group ID. So this is so that if we scale, i.e. if we have more instances of the same application, they can basically read from the same partition or topic. So here I'm going to say group ID. So group ID. And for now, this is a bad name, I know, but I'm just going to say foo, for example, right? Or you could say group ID. But as you have more listeners, then you want to change this so that it's unique. Now in here, I can then just do anything I want with this data. So for now, I'm going to say south and full screen received or listener received and then data. And let's add an emoji there. So I want to have an emoji here and I'm going to choose the tada. Yeah, there we go. Tada. There we go. And we are good to go. So I've got typo here and job done. Now let's try and restart and see whether this works. So let me restart the application. And currently, let's have a look. So you can see that we have group ID, which was assigned. And I think at this point, so I think I need to restart. Let's just see. I think I need to restart once more. But yeah, there we go. Have a look. So now we're actually reading from the topic, right? So we've published a bunch of messages. So here, have a look. We did publish before Kafka application. We published all of these messages in here, and then we consume them inside of this listener. So if I go to run, you can see that we have tada. So also remember, if I go back to my terminal in here, so this was open. Have a look, right? So I've got another consumer. So what we have is we have two consumers reading from the same topic. Next, all we need to do is to build a RESTful API that allows us to publish messages to a queue. Let's go ahead and do that next. So to build an API, let's within the main package, let's just have a message controller class. And here, let's annotate this with @REST controller and @request mapping. And this will be API v1 and then messages. And let's have one single method here. So public and then void, and this will be publish, and we're going to receive, a message request. So in our case, let's just have a record. So class, and this will be message and then request, and this will be a record, and inside I'm going to say message. So now at and then request and then body, and from it I want to get the message request, and all I'm going to do is, so obviously I could structure this into services, so on and so forth, but for now all I'm going to do is I'm going to inject the Kafka template. So here private and then Kafka template, this will be string and then string and Kafka template, and inside I'm going to say Kafka template dot and then send. I'm going to put into Amigos code topic, and in here just say request dot and then message. And also we need to have a constructor here, so constructor, and things are now auto wired. And because we want to expose this method to our clients, we need to say at and then post and then mapping, so that we can issue post requests against it. So let's just reload in here, and for this you could use pretty much any REST client, but within IntelliJ I can just say generate requests in HTTP client, and this will be 8080 messages, enter. And I think so, let's just have a look. Examples, post request, and I need this guy here, so let me just take this and then go back and paste that in, and the content, so here, so this will be message, and I can pass anything. So here I'm going to say API with Kafka. Now if I send this request by just pressing this play button, there we go, 200 status code, and open up run, and if I scroll up you can see the headers as well as the URL. If I open up run, have a look. So this is good stuff. So listener received API with Kafka. So let's just say here, hooray, Amigos code, send the request. There we go. Go back to run, and hooray, Amigos code. So you can see that our listener, i.e. the consumer, is receiving streams of event of a topic. So we've got a RESTful API, we publish to a topic, and the consumer reads it out. So we pretty much have built a RESTful API with Kafka integration. Also, if I show you the other consumer, which is running on my terminal, you can see that here it says hooray and then Amigos code, API with Kafka, and we are good. If you have any questions, please do let me know. Otherwise, catch me on the next one. So far, you've seen that when we send this post request in our controller, have a look. So our Kafka template takes the key as a string and the value as a string. And then here we send just the message. But let's say that you want to send a custom object. So how do you do that? So instead of just a string, you want to send the object as a whole. So let's open a project, and in here, let's create a new class, and I'm going to name this as message, and this will be a record. And inside of this message, let's just have the string and then message, and also the local date and then time. And I'm going to say created at. So put this on a new line, just like that. So you can see that now we do have the message here, as well as the local date created at. So inside of our controller now, we basically want to convert that message request, so this message request, into the message. So here, let's just say new message, and let's pass the message from the request, and then the timestamp, so local date, and then now. So let me extract this to a variable, and this is now the message that we want to send. But obviously, if I try to send a message here, so message, you can see that I can't, because the value has to be a string. So let's change both the consumer and producer so that we can work with objects. So let's open up the producer first, Kafka producer config, and inside of this class, we have to change a couple of things. One is the producer config value serializer class. This no longer is the string serializer, and instead it has to be, so in here, let me just change this to JSON and then serializer. And this comes from the Spring framework, not the one from Jackson. So there we go. The next thing, so in here for the producer factory, this has to be a message, just like that. Let me copy this and do the same for our Kafka template, right? So we want to send our message in here, and when we inject the producer factory, we need this one, right? So it's string and then message. So let's just reflect in here, string and then message. And this is all for this class. Next, let's open up the consumer config. And in here, we have to do a couple of things. So what we need to do in a nutshell is we need to change the consumer factory as well as the Kafka listener container. So here, the type will be message. And what I'm going to do is so here, we can actually pass some extra arguments. I'm going to say comma, and then have a look. So deserializer as well as value deserializer. So what I want for this guy right here is to have the key as a string. So string and then deserializer. And this should be new, just like that. And then invoke the constructor and then comma. And also you can see that we can pass the deserializer value. So the value will be new. And then I can say JSON deserializer. So the same thing that we've done for the producer, just like that. And in here, we can actually remove this. So let's just remove from this config. And we only have the bootstrap servers in here. So now we also have to change the factory. So Kafka listener container factory. So here, this has to be a message. And when we inject the consumer factory, which is this guy right here, it's no longer a string, but a message. The same for the concurrent Kafka listener container factory. So this has to be a message. And there we go. Now, obviously, if I open up the controller now, we have to change the template because, so have a look. So when we configured the producer, we configured Kafka template in here. So the key is a string and the value is a message. So let's just change this. So back to our controller. So this has to be a message. The same here. And now in here, we can just pass our message. So I'm going to say message. There we go. And I think within the main, so Kafka application in here, let's also change this because otherwise it will fail. So this has to be message. And then here, let's just basically take this string right here. And I'm going to say new and then message. And I'm going to pass the message, comma, and then local date and then now. And let me just put this on a new line so it's easy to read. And also let me just indent things properly. And now you can see that it's easy for you to read. Obviously my font is quite big and usually I wouldn't have this kind of formatting. So now we are good to go. So before, remember, so when we ran, we had listener received, hello Kafka, but this was a string. So now let's just take this right here. So I'm going to hide. And if I restart the application and check this out. So now we are sending a JSON object. So have a look. So all of these, so they're about 1,000 or 100 actually, I think. So that's what we had in our loop. Yes, 100 in here. So we have 100 messages right here, and you can see that they are in form of an object. Now, we're not quite there yet, but you can see that this is kind of working, right? So our producers, so here we are basically sending a message, and also the controller is sending this message, which is an object. If I open up run, and in here, let me just put this a bit smaller, go to the top and just delete all of that and open up my HTTP client, and let's run this request right here. So HTTP localhost API v1 messages, and this is the payload. Have a look. This is the payload, which is the entire object. If I say run, and now let me just go back to run again and have a look. So this is our message. So if I say hello John, for example, and send, go to run, and you can see that this is working. Now this is not quite there yet, and this is because if I hide this and open up the listener, so let's just open up the listeners, so here, and have a look. So in here, our listener accepts a string right here, and then it basically prints the string. But what we want is to change this from a string to a message, which is our Java object that we've just created. So let's tackle that next. In order for us to change this string right here, so when we publish a message, which is our custom class, we have to change a few things. So one is, if I change this to message in here, and let's just try and run this, you should see that this actually, it's kind of working and is, you know, going through all the messages, which is 100, but it's failing. And if I stop this and then scroll to the top, you'll see that we have this message in here. So illegal argument exception, and it says, so if I scroll here, the class com.amigos code, it's not in the trusted package, and then java.util or java lang. If you believe this class is safe to deserialize, please provide its name. If serialization is only done by a trusted source, enable trust all and then star, right? So what we need to do is, if I collapse this, and within our consumer config, so within consumer config in here, so Kafka consumer config, so at this point here, so where we use the JSON deserializer, let's extract this to a variable, and I'm going to say deserializer or JSON deserializer, and here we need to customize this. So here, based on the message that it just told us, I can say json.deserializer dot and then add trusted packages. So here you can actually add a custom package. So here I can say com.amigos code, which is my package currently. So here com.amigos code. So anything within this package, I do trust. So I could do that, or I can say star. So if I show you again the message, so it's only done by a trusted source. You can also enable trust all, which is this guy right here. So in my case, let me just stick with com.amigos code. And now if we run this, there we go. You can see that it did work. And at this point, have a look. So message, and then this is the message in here, and then created that, and have a look. So this is kind of cool. So we actually done it. So if I go back to the listener here, I can say message dot, and then get the individual fields. So message maybe, and you can basically say to uppercase or lowercase, so on and so forth. But at this point, you can see that it's using the toString to basically print out the message, and we successfully managed to change our producer from producing a string as the value to a custom object. Now, obviously, if you want to have other objects, you basically just have, so in here, you have a bunch of these consumer factories based on the object that you want, or there are other ways that you can basically customize it further so that you don't have to repeat code again and again and again. But hopefully this explains the overall process, and I think that we are done. If you have any questions, drop me a message. Otherwise, catch me on the next one. So in here, you see that I do have this consumer, which is also receiving all the messages correctly as an object. This is the broker right here. So this is the broker which is up and running, and Zookeeper server, which eventually you won't need to run this as they stated on their documentation. But I think we done it. So if you want to stop things, you could just basically press Ctrl+C on this consumer, then on the broker, and then on Zookeeper. So this is when we are running things locally. If you want to run things on the cloud, on Google, you can search for Managed Kafka, and you'll get a bunch of ads. But in here, if I scroll down, you should see one from AWS. So a fully managed Apache Kafka. Click on it, and in here you can see it says secure stream data with fully managed, highly available Apache Kafka service. So it eliminates the operational overhead. And this is really cool because now you don't need experts in the house that know about how to manage Kafka. Everything is managed for you. So you can reduce costs that way and reduce overhead, meaning that engineers in your organization can just focus on their business logic instead of having to understand all the ins and outs of Kafka. So here you can see how it works. So basically this is the managed Kafka, the orange boundaries, and basically you create a cluster and you could have your EC2s, Lambdas, Kinesis, and they connect producers and consumers to Amazon managed Kafka. And you can see the use cases, customers, so on and so forth. So I would say maybe if you want to deploy things, this is a good start because you don't need to be a Kafka expert in order to deploy applications that use Kafka. If you want to learn more about Spring Kafka, navigate to spring.io, then click on projects and then Spring Boot. And right here, if I scroll down, you should see that there is a link for Spring for Apache Kafka. If I click on that, and you can see that it gives you the overview, and we went through all of this, but basically in here, so if I click on learn, and you can see the reference docs, let me just click on that. And in this page, there is everything you need to know about using Kafka and Spring Boot. So if I scroll down, it's quite an extensive documentation, which I recommend you to read. So you can basically, if I click on the reference, have a look, configuring topics. It gives an example in here, sending messages. So this is what we went through right here. So this is it. To be honest, if you have any questions, please do let me know. Otherwise, catch me on the next one. So hopefully you see the benefit of using Kafka. Now, I just wanted to give you this crash course, but now you should know how to take everything that we've built, so the consumer as well as the producer, and then change it to our existing application. So I'm going to leave that a homework for you to do. and I would like to see your implementation. Let me know how it goes. In this diagram, you can see that we have this config server right here, and this is mainly for pulling out configuration. Now, if you're using Spring Boot, you'll often see people using the config server, but I'm going to tell you that it's best not to use it. So let me actually first show you what Spring config is, and then I'm going to tell you why you shouldn't use it. And within Spring Cloud, you can see that we have Spring Cloud Config, and Cloud Config provides server and client side support for externalized configuration in a distributed system. In here, you can see that if you have your microservices and they want to pull out environment specific configuration, they can do it through this config server in here. So you don't have the configuration within these services themselves, but it's externalized through this config server. Now, this config server serves all the configs through HTTP. So it's actually running a web server and then serving all the configuration for these microservices in here. Now you can see that if this, for example, was to go down, then you are in serious trouble. So if I put this back, and basically it's best for you not to use this. And that's because we are using Kubernetes. Often if you build these microservices, most of the times you will deploy these applications to Kubernetes. So this is the Java stack these days. And within Kubernetes, there is something called config maps. And within the official documentation for Kubernetes, there is this config maps page. And by the way, I'm going to leave this link under the description of this video so you can follow along. But in here, they say a config map is an API object used to store non-confidential data in key value pairs. Pods can consume config maps as environment variables, command line arguments, or as configuration files in a volume. So this is the perfect scenario for us to use config maps. And the benefit of using config maps is that we don't have to manage this ourselves. So here, one less server to manage. And you can imagine if you have thousands and thousands of microservices, then you need to make sure that your config server is resilient, so on and so forth. And basically, we can remove all of this from our concern and focus on building our domain. So each of these microservices, and we let the configuration be taken care by Kubernetes, which is what you should be doing. Let Kubernetes manage the configuration for you. And within Spring Cloud, so there is Kubernetes, have a look, Spring Cloud Kubernetes, and I already have this link right here. And if I click on it, in here, section 14, you can see that they give you a explanation of what a config server is. But what I want to show you is that it says that this component is completely optional, right? So usually the reason why people use config server is because it allows you to store configuration within Git, for example, but please don't do it that way. And instead, so in here, section 5, Kubernetes property source implementations, you can see that it says the most common approach to configuring your Spring Boot application is to create an application.properties or YAML, or the application dash the profile, as you saw throughout this course. Now it says using a config map property source, Kubernetes provides a resource named config map, which I've just showed you, to externalize the parameters to pass to your application in the form of key value pairs or embedded application.properties or YAML. And then it says the Spring Cloud Kubernetes config project makes Kubernetes config map instances available during application bootstrap and triggers hot reloading of beans or Spring context when changes are detected or observed within your config map instances. So you can see that there is no need for us to manage our own config server, and we let Kubernetes, which is amazing at what it does, deal with stuff that we really don't care about. And for configuration, there is no need for you to spin up a config server because, as I said, you don't want to manage it. And the more microservices you have, the more difficult it is for you or your ops team to manage infrastructure. So please just use config maps. If I scroll down, you can see that they have an example here. So basically, Here, have a look. So you can have a config map like that, and then you specify the size. So this is in properties, format, or have a look. So individual properties work fine for most cases. However, sometimes embedded YAML. So you've seen application.yaml right here, and have a look. Basically, this is a Kubernetes resource, and then you can pass a data. This is the name of the file, and this denotes the actual data right here, and this is the file. And then you can basically mount this as a volume. So again, I've got a course on Kubernetes teaching you everything about config maps and whatnot. So I highly recommend you to have a look at that. But what I want to tell you is not to spin up a config server. Please don't do it. And as you saw with Eureka Server as well, we basically eliminated all of this. And you can see that now is less to worry about. If you have any questions, drop me a message. Otherwise, let's move on. If you want to manage your secrets and protect sensitive data, Vault is here to rescue. Vault allows you to secure, store, and tightly control access to tokens, passwords, certificates, encryptions, keys for protecting secrets, and other sensitive data. So it's actually open source if you want to manage yourself, or you can use a cloud managed Vault. And with Spring, they have an integration in here. So I'll leave these links so you can follow along. But Spring Cloud Vault Config provides client-side support for externalized configuration in a distributed system. With Vault, you have a central place to manage external secret properties for application across environments. So secrets, these are database passwords, API keys, and whatnot. So we're not going to learn about Vault and how to configure it and whatnot. So this usually is part of the DevOps team, and they are responsible for managing all of this stuff and configuring it. But I just want to let you know that you could use Vault to manage your secrets. If you have any questions, drop me a message. Otherwise, let's move on. Another important service that I want to talk to you about is the reporting microservice. So you see that we have 3 microservices, and we are using Spring Data JPA. Spring Data JPA doesn't really work well if you have long queries, i.e. queries which are used for reporting purposes. So instead, what you do is you have another microservice called reporting, and then all of these 3 microservices that we have pushed all of the data into this microservice called reporting. At that point, you can then use Spring JDBC, and you can write raw SQL queries and have your DTOs and whatnot. So that is what you should be going for. The benefit is, you can imagine if you have a long query that takes, for example, 1 minute or so and can cause load on the database, then you are executing those queries of the main microservices that receive real traffic. So maybe you want to run a batch process overnight, then you can do it off the reporting database. Now, one thing which I want to mention is maybe you are interested in live data, for example. Well, you saw that with Kafka. Kafka has something called Kafka Connect, which allows us to take data from our Postgres database into a Kafka topic, and then from that topic you can actually consume that data. So you can see the possibilities there. Now, we're not going to implement all of this, but I just want to make you aware of the reporting microservice and how you should use it. If you have any questions, please let me know. Otherwise, let's move on. All right, so let me touch on security, which is a big topic. And unfortunately, in this course, we're not going to cover security in detail. Security is a course on its own. And luckily for you, I'm actually planning a course on security. Now, currently as it stands, you might be saying, right, so if we have secured the load balancer or the API gateway, then surely that is a big flaw. Yes, right? So you should never keep your security focused on the main entry point of your application. So as you saw within the diagram, the application is within a private network. So there are a couple of things that you can do in there. One, you can have security rules or network security rules. So one microservice can talk to another, this can talk to that one, so on and so forth. Or if you are using Kubernetes or deploying to Kubernetes, then there is something called a service mesh, which helps you solve all of this. I've got a course on Spring Security, and that course is actually, I'm actually going to revamp that course because the documentation for Spring Security right now is actually changing. And what they actually introduced into the new version of Spring Security is the OAuth resource server. So this is a perfect example of how we should secure each microservice. So each of these microservices, they will act as a resource owner, therefore allowing other microservices to talk to it by initiating the OAuth flow. But again, all of this will be found on my security microservices course, which is not ready yet. So if you have any questions, please do let me know. Otherwise, let's move on. All right, let's talk about deployment and how you would basically take all of this, everything that we've implemented, and deploy it to a cloud provider. So I'm going to show you the most popular one, which is AWS, and some of the services that you will need. And the first thing that I want to talk to you is basically in here. So you see these microservices, so customer, fraud, as well as notification, and we kind of package them into a Docker image, correct? Now, you don't want these Docker images, so your applications, to be public. So currently they are public. If you go to my Docker Hub registry, in here you can see all of my registries. Have a look. You've got API Gateway, notification, Eureka Server, fraud, customer, and whatnot. Now, with Docker Hub, you can have a private registry, meaning that for applications to access, they need to provide credentials. So you are the only one that can access these images. You could use Docker Hub, or you could use Amazon Elastic Container Registry. So if you're deploying everything into Amazon, you could just use Amazon ECR. So easily store, share, and deploy your container software anywhere. It's very easy to use and kind of similar to Docker Hub. Then the next thing that I want to talk to you is this main entry point. So our load balancer that we've configured. Now, as I said, we don't want to manage our own load balancer, and instead we should use a managed one. So AWS, they provide elastic load balancing for us. So it's a managed solution that allows you to distribute network traffic to improve application scalability. You can secure your applications with integrated certificate management, user authentication, SLS, and SSL TLS decryption. You can deliver applications with high availability and auto scaling. So this is something very difficult for us to achieve, and you can monitor the health and performance of applications in real time. So you can basically uncover bottleneck and maintain SLA compliance. So really important. Now, in terms of how it works, so here they've got a few types. So you've got application load balancer, gateway load balancer, and network load balancer. So you need to choose accordingly, but most of the times you're going to use application load balancers with ingresses within Kubernetes. So basically have a look. So in here, this is the source. In here, you've got the load balancer, and you get all of this right here configured for you. So you see that if we were to manage our own, to get all of this, it's a really difficult job. But then with this application load balancer, you get user auth, rich metrics, logging, redirects, fig responses, and you can do content-based routing, health checks, sticky sessions if you want to use, and you have lots of different load balancing algorithms to choose from. And have a look, the targets: EC2, Lambdas, Fargate, EKS. So in here, I'm going to touch on EKS in a second, and also ECS, or to an IP address. So this is really, really powerful stuff. Then we have our databases in here. So Postgres, again, we can use Amazon Relational Database Service, i.e. ODS. So set up, operate, and scale a relational database in the cloud with just a few clicks. It's super easy to use and to manage. So here we've used Postgres, but you can use MySQL, MariaDB, Oracle, SQL Server, and Aurora. So you can see the benefits in here: high scalable, it's fast, secure, inexpensive, expensive and a bunch of people use it. So you should also use it. Then you saw that these microservices, they connect to a message queue. So we learned both about RabbitMQ as well as Kafka. And again, for us to manage our own message queues and whatnot, it's difficult. So instead, use a managed solution. And luckily for you, there is Amazon MQ, fully managed service for open source message brokers. And you can read more about it, how it works and whatnot. But here, build or configure your message broker, producers, and consumers. So we've learned about all of this. Also, Apache Kafka. So Amazon manage streaming for Apache Kafka. So you can use Apache Kafka within AWS. So never manage your own message queues unless you know what you are doing. Finally, you saw that we don't need Eureka Server nor config server. And distributed tracing also, this basically it's very easy to deploy as you saw within our Kubernetes cluster. But the last thing that we need is, so you saw that we deployed all of this into Minikube. Now Minikube is mainly used for local development. And if you want to deploy your microservices to a Kubernetes cluster, then you can use Amazon Elastic Kubernetes Service, i.e. EKS. The most trusted way to start, run, and scale Kubernetes. So it's really nice. I've used it in the past, and basically in here you saw Fargate. So this is serverless containers or EC2. So basically you can deploy worker nodes for your EKS cluster, and a lot of people are using it, and it's really powerful, and it's one which I highly recommend it to use. So this is pretty much all the components that you need within AWS. Like literally just learn AWS, because everybody deploys their applications to Kubernetes because it's so cheap. And if you know AWS, you can demand for more money when applying for jobs. I'm going to leave all of these links under the description of this video so you can follow along. But if you have any questions, please do let me know. Otherwise, catch me on the next one. Okie dokie, I'm super happy that you've made this far. I know it was a long course, but hopefully you can see the benefits of using microservices from start to finish. How we started with one microservice, then the communication between two microservices, three microservices, service discovery, packaging up the application, distributed logging, Jib, Docker, Kubernetes, Kafka, RabbitMQ, and pretty much this is what, if you were to work for a company, then this is a good solution for you to start implementing microservices. Or if you are learning microservices so that you can apply for jobs, then you could pretty much just use this course and talk them through like what you've built. Literally talk them through how you've built all of these microservices, and I'm pretty sure you will impress and get the job. It was a pleasure teaching you. Let me know what you thought about this course, and I would like to hear from you. Also, I would like to ask you if you want to be featured on my website. So this is you recording a 3 to 4 minute video introducing yourself and just giving your honest opinion about this course. And also what you think about Nelson as an instructor. I'm going to leave the questions to help you record the video if you are interested. And if you record the video, I will be really happy and feature you on my website. So have a think. This is all for now. Keep in touch on the Discord community. And if you have any other questions or things that you are planning on working on, let us know. So for now, I'll catch you on the next one. Assalamu alaikum.